standard parameter. We not follow the standard algorithm. Kalau heuristic like a GA have a standard what we call standard procedure.
Alright. Got it. Thank you.
Except you consider parameter control. Okay, parameter control consider heuristic, but parameter tuning consider random, try and error. Boleh?
Alright, okay.
Because consider parameter control, we ask computer to do to find the best parameter, and then to find the best parameter, we should put some what we call standard algorithm. So that's how we can say that for parameter control. So we can consider as a heuristic, but for parameter tuning, consider not heuristic. So you all tak ada buat final FYP optimization? Ada? Tak ada?
Saya buat juga.
You buat? You buat tajuk apa?
Optimization for unnecessary purchases.
For what?
Unnecessary purchases. Dia macam kita nak optimize cara penggunaan kita dalam pembelian barang lah, untuk detect sama ada
Your supervisor?
Dr. Marina.
So make sure. So how you define the fitness function?
From that now, I still thinking about it, but buat masa ni saya akan sediakan survey lah untuk tanya pendapat orang, and then from that result saya akan sediakan based on data yang macam the spending of kita lah, macam berapa banyak people spend masa tu, kat situ yang saya akan sediakan.
Yeah, but I takut you stuck, you know.
Yeah.
Stuck. Kalau you tak boleh nak solve the fitness function, so how you want solve your project, your title? Kalau fitness function
itu akan diusahakan secepat yang boleh lah, sebab macam tajuk optimization ni pun baru lagi bagi saya, jadi banyak benda lagi yang saya kena tengok.
So you try download article or journal related to purchasing punya issue, then tengok how they define the what we call fitness function.
Baik, doktor.
Kalau tak you stuck nanti.
Doctor, I'm thinking of adding DA into my FYP as well.
Okay, your area, your problem.
My problem is I'm trying to identify mental illnesses. So what I'm thinking of is I'm going to use ANN, artificial neural network, and then instead of running the program X times, I'm going to use GA. So meaning train the ANN. So for instance, I'll create 5 ANNs, and then I'll train it. From there, I will choose like 2 ANN architectures which are the best. From there, I will do crossover, and then I'll do the training again.
Your supervisor?
My supervisor is Dr. Shamimi, and I'm thinking that the fitness function would be the accuracy of the ANN model. Do you think that is valid?
I'm not so sure because it seems like hybrid. This is hybrid technique or what?
It is hybrid, yeah.
Hybrid lah.
Yes.
So I don't know. Maybe for me very challenging, very challenging to implement. I don't know. Try your best. I don't know. No idea. Because you need to consider two things. First, ANN and optimization. Another one. Then the programming skill must very strong. You must have a skill, not intermediate skill, not strong in programming. So satu, dan yang kedua, the idea of how to implement tu, how to hybrid. Tu satu hal lagi. Hybrid with AN and PGA. I takut you stuck, to be stuck. So make sure you have what we call clear direction. Kalau you not sure the direction, the goal, the next, so make sure you think twice before you proceed.
Sir, macam kalau saya kan, saya nak buat genetic drawing. So kalau macam atau genetic painting, macam rasa susah.
Painting no, you dah belajar kan, GA, the orang kata apa, the what we call the most difficult part for optimization to generate a mathematical representation for that problem. Kalau you dah boleh solve the mathematical representation, so yang lain just follow the algorithm tu aja. Yang tu very easy. Not lah easy. That one very, yang kata apa, clear direction. But the difficult part, the most difficult part for optimization is to mathematical tadi. Mathematical tu macam mana? Kalau you rasa you can find or you can think about mathematical fitness function tu. So I think okay. Kalau you tak boleh nak represent.
So maksudnya kalau dia punya fitness function saya buat macam gambar asal. Total error of gambar asal dengan gambar yang genetik tu buat. Faham tak?
Tahu. Tapi macam mana you nak dapatkan equation tu? Mathematical equation tu. Kalau yang TSP, traveling salesman problem, mathematical equation fx equal to summation of xi. Yang tu total of distance. Yang tu kalau dah dapat yang tu, yang lain just follow aja. Buat generate chromosome and so on. We just do crossover, mutation and so on. Yeah, that one standard process. But for your case, the image tadi tu, how to represent, macam mana nak buat tu. Kecuali you dapatkan artikel, dekat artikel tu dah show the equation, the mathematical expression for that problem. Okay, that one just you ambil aja.
Oh, okay. Kalau saya buat sendiri tak boleh?
Kalau buat sendiri, macam mana you nak buat tu? Cuba you imagine macam mana?
Saya pun tak terpasti.
Yang tu yang paling susah
saya
sekali.
Cuba sebab saya macam nak combinekan macam
Dia supervisor siapa?
Saya punya Dr. Shuzlina.
So make sure apa? You tahu macam mana nak dapatkan mathematical representation for that problem.
Macam saya guna yang macam ni. Lepas tu gabung dengan
Tapi dekat internet I think ada artikel pasal image tu. You cari je dekat internet artikel. Download.
ayat yang tu ada paper dia.
Ada paper kan? Ada paper boleh. Maksudnya dia macam mana mathematical representation dia buat? Susah ke senang?
Tak baca. Tapi saya tengok kod je lah. Saya baca kod. Tak apa kod.
Cuba tengok macam mana dia manage. Okay, tak apa. Alright. So can we start? So okay dah, student dah ramai.
Saya gabung dengan macam ni lah. Macam saya tengok kod yang ni.
I tak nampak you punya sharing ni, tak ada.
Oh, saya kasih link. Tu
Oh, link. Okay. Sekejap. Sekejap check.
Macam dia buat stage by stage. Saya mungkin buat dalam serentak kot. Macam dalam 5,000 brushes. So 5,000 tu dia kira jeans lah kan.
Okay lah, boleh lah kalau you dah ada ni. Dah ada apa nama?
Sebab ni dia present
Dah ada what we call
presentation. Kau main lagi ke? Main lagi cafe?
dah ada final function. Boleh lah kot. I'm not sure. Tengok tak apalah, nanti kita display tengok je lagi. Keren-keren. Okay, so for tutorial today, share. Sekejap. Okay, nampak tak? Share screen. Nampak? Okay. So, for today, we try to solve next set problem using genetic algorithm. Okay. So, next set problem is a problem in combinatorial optimization. Given a set of items, each with weight and value. So, we need to determine the number of each item to include in a question so that the total weight is less than or equal to given limit and the total value is larger as possible. So, for example, consider this what we call this problem like this. So, we have two variable. that we should consider. First, weight, and then the value of variable, or the value of item. For example, for one box, this is the box. Okay, then we set a limit for this box. The maximum weight we can put or we can keep, maybe weight maximum less than or equal to 20 kg. Okay, or 200 kg, up to you lah. And then for the weight, we have many items. For example, item number 1, item number 2, item number 3. Okay, item number 10 till, for example, we have 10 items. Okay, and then each item have weight. For example, item number 1, 2 kilos. Item number 3, 4 kilos. Item number 5, number 3, 5 kilos. And then so on lah. And then item number 10, maybe 3 kilos. And then for item number 1, value or price. Okay, value, maybe for item number 1, maybe 10 ringgit. Item number 2, 50 ringgit for one item. For item number 2. And then the weight is 4 kg. Item number 3, 5 kg, maybe 100 ringgit, and so on. And then item number 10, maybe 70 ringgit, and so on. So now we need to determine which item should we put inside this box, with maximum weight 20 kg or less. And then we try to find the highest price or value for item. So we using GA to solve this problem. Clear the problem?
Clear, sir.
The problem situation clear kan? Should I explain again? No need. Yes. Perlu ke tak?
Clear, sir.
Yang lain?
I'm okay.
Clear? Okay. So the weight, we have constraint here. Constraint, we set the limit, and then the value, we try to find the highest price or the highest value. So we ask genetic algorithm to decide which item should we put or should we keep in this box. Like this lah. We have this another example. We have a bag, and that's in this bag. The bag, so maybe the maximum value 15 kilos and so on. Depend how we depend on ni lah problem. Okay, then the fitness function for this problem, so we can define like this. X multiply P. X for item or weight, and then P for the price summation with P ni. P equal to weight lah. P less than the total P. For this case, we using this formula, sama je. Okay, I show you. Fx summation xi multiply wi. With w must less than the total weight. Okay, this is our what we call fitness function for this problem. So how to solve this problem using genetic algorithm? Okay, so we're using this is the algorithm, the pseudocode for next set problem using GA. Okay, and then first, okay, after we define the fitness function, we need
Kau
to
main lagi ni.
think
Apa?
how to represent the problem. Problem representation for chromosome macam mana. So for this case,
My cafe.
for example, because we have 10 item, so we need to allocate 10, what we call 10 bit. 1, 2, 3,
Kau beli
4,
je dia punya
5, 6.
duit semua.
Okay, 7, 8,
Ha?
9, 10. 2, 4. Okay, 10. 10 item. And then, for example, for 10 item, for example, the bit like this, for example, 10, 11, 0, 1, 1, 0, 0, 2, 4, 6, 8, so 1, for example. Mean 1 represent yes. 0 we represent no. Yes mean we select item number 1. After that we select item number 3. Item number 4. Okay, this is item 1, 2, 3, 4, 5, 6, 7, and 10. The item involved, item number 1, number 3, number 4, number 6, 7, and number 10. Like this. Okay, so for this chromosome, we can evaluate this chromosome based on the item number 1. Item number 1, for example, like this. Macam ni. Item number 1, like this. Item number 1, weight 2, value 10. Item number 2, weight 3 kgs, value 20. So for this case, the 1, 0, 1, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1, 0, 1, 1, 0, 0, 1. 1, 1, 0, 0, 1. So, how to evaluate the fitness function for this chromosome? So, mean 2 multiply, because item number 1 kan? This is item number 1, item number 3, item number 4, 5, 6, 7, and 10. 2 multiply 10 plus item number 3, 5 multiply 30 plus item number 4, 3 multiply 5 plus item number 6, 7 multiply 40 plus number 2, and then item number 7, 6 multiply 60 plus item number 10, 2 multiply 6. So total maybe 100, maybe 90. For example lah. Okay, so the quality of this chromosome equal to 90. Clear?
Clear, sir.
Clear, sir.
And then for this case, I set W mass less than or equal to 25. So we need to check 2 plus 5, 7, plus 3, 10, plus 7, 17, plus 6, 23, plus 2, 25. Okay, ngam-ngam, 50. Okay, so this chromosome mean consider valid. So we can consider as a valid chromosome lah. Tapi kalau another example, for example, 10, 11, 11, 1011, 1011, 111001. So this one not valid because the weight more than 25. So you cannot choose this chromosome. Clear? First, you need to check the weight of the total item, and then after that, you need to evaluate the quality of chromosome. If weight more than 25, mean you cannot use that chromosome, so you just remove. So you need generate another chromosome by random for first iteration, okay, initial population, and then you based on GA, you just follow the same process of GA, mutation and crossover and so on. For example, for the initial population, maybe you can put 4 population. So 4 population by random with 10 bit for each chromosome. Then you need to evaluate. If more than 25, mean the chromosome not valid, and so on. So can you show me the process using GA at least 4 iteration? Boleh faham ke? For next set problem using GA, should I explain again? Oh, no need.
Nanti kalau guna GA, doktor, if kalau yang nilai dekat iteration GA weight tu lebih daripada 25, nak kena ambil return yang sebelum ni ke?
Kalau lebih daripada 25, so that chromosome you just remove aja lah, no need to consider.
Oh, okay.
So you need to produce another chromosome.
Alright, got it.
Yeah. So I know you try to solve this problem manually using genetic algorithm and show me your work for at least minimum 4 iteration. You need to repeat the process 4 times. Iteration mean the process lah. 4 kali proses yang sama tapi berbeza value lah, berbeza chromosome. But the same procedure. Okay, using this table, okay, we have 10 item 1 till item number 10, and each item have weight and value, and then I put constraint here, the weight for this case less or equal to 25 kilo. Okay, show the process using GA. So macam mana nak buat? Show me the process. Boleh buat ke tak? You rasa you boleh buat ke tak?
InsyaAllah, sir.
Boleh kan?
We will try.
Okay, so yang lain rasanya boleh ke tak?
Sir, so have you set the requirements, as in the number of initial population, the type of crossover,
Okay. So for the criteria, so at least you put 4 population, initial population 4, equal to 4, and then mutation rate equal to 5%, Okay, mutation rate. Lagi apa? Itu je lah. And then you need to show 4 process or 4 iteration. And then 4 iteration. Show me the process.
Doctor, what is the type of crossover and type of mutation?
Crossover, okay, for crossover by random. Crossover random mean you can based on point number 1, point number 2, point number 3, up to you. They are random. I want you just show me the how the genetic algorithm work. Okay, by random crossover random.
Okay.
Random
so for
point.
the mutation type?
Mutation type just flip. Kalau 1 change to 0, 0 change to 1.
Okay, bit flip mutation. Right.
Yeah. Okay, show me the process and then so sekarang baru pukul 10, setengah pukul 11. Bila you boleh siap? 1 jam? Tak boleh?
No, sir. Minggu ni overwhelming, sir.
Iya kah? So,
For me at least.
So you prefer by today or by end of this week? By Sunday, can lah? Or by today?
I let my classmate decide on that.
By Sunday sih.
Sunday. Okay.
Saya pun okay by Sunday.
Okay lah. So kalau by Sunday okay, nanti you submit. Then
Submit kat mana sih? Dekat iDiscuss?
I discuss.
Okay.
Dekat I discuss. So ada soalan lain? Tak ada? Kalau tak ada, I nak start kat sini today. So next week we start new topic, particle swarm optimization. You nak particle swarm dulu ke ACO dulu? Dekat dalam ni, I buat apa dulu lah? Dekat dalam plan of study? I not sure, tak ingat. Tak apalah.
Which one is easier, sir?
Dua-dua interesting. Tapi ACO,
Saya tu.
for me, I prefer ACO compared to PSO.
Okay.
Sebab ACO, I don't know, I seronok tengok PSO compared to PSO. Sebab ACO like N kan, N colony, so like kita tengok macam pheromone, we study pheromone, we study how the N tu macam mana, the community, the colony dia tu. So based on that what we call that situation, we do the what we call the simulation using ni lah algorithm based on N punya character. Tak apalah, nanti we discuss during class. So that's all for today. So see you next week.
Doctor, I have one more question. I don't understand the mutation rate.
So mutation rate like this.
When you say it is 5%, does that mean each chromosome in the population has a 5% chance of mutating?
No, like this. For 5%, like this. Okay, we have one chromosome, we have 10 bit. So because we the total population equal to 4, so mean the total bit equal to 40 kan? 40. So 40, so 5% ni from 40 ni, so 500 multiply 40, so mean how many bit? 2, 1, 2. So for one chromosome, second chromosome, and then so you just by random, maybe chromosome number 1 and chromosome number 4 only involve, just flip one bit je lah. Faham ke? So not clear or not sure clear?
Can you repeat one more time? Last one.
5%,
Mhm.
because total we have 40 bit, because
Yep.
one chromosome equivalent to 10 bit.
Okay.
So we set here 4 population. 4 population mean 4 multiply 10 bit, so equal to 40 bit, the total.
Mhm.
So we set mutation rate 5% of 40 bit, so 100% multiply 40. Clear?
Okay.
So
Okay.
equivalent to 2 kat sini.
Oh, I see.
Equivalent to 2. So 2 randomly you just flip 2 times. Maybe chromosome number 2 involved, and chromosome number 3, and chromosome number 1 and number 4 no need to touch. Just you modify chromosome 3 and chromosome number 4, just 2 time only, 2 bit only. You flip, kalau 0 change to 1, kalau 1 change to 0 by random.
Okay. So choosing 2 chromosome, and then for each chromosome just choose 2 bits at random.
Yeah.
Okay. I
That
think I
one
got
for
it.
5%. If I change to 10%, 10% equivalent to 4 bit. 4 bit. 4 bit you need to flip. So maybe chromosome for chromosome number 1, maybe 2 times here, but chromosome number 3 no need to touch. Chromosome number 1 only 1 bit. Chromosome number 4 1 bit. So chromosome number 1 maybe 2 bit involved. Up to you. Clear?
Okay, I think I'm starting to get it now. Yes. Thank you, Doctor.
Okay, lain? Yang lain? Ada lagi? Tak ada?
Betul.
So kalau tak ada, so stop kat sini. So see you next week. Assalamualaikum. Make sure take attendance. Make sure take your attendance. Okay, bye.
Thank you, Doctor.
Bye.
Thank you, Doctor.